So far with our space figures, we've only looked at naming parts of them, but in 11.2 we're looking at our first couple figures, which are prisms and cylinders. We're going to look at those, we're going to find the surface area of those. So to find surface area with any 3D shape, we're going to find the sum of the areas of all the surfaces of that figure. So you can kind of imagine if I made my 2D drawing and kind of unraveled my figure, I'm just looking for the area of each side and then adding all those sides together. So a prism is what we call a polyhedron with two congruent and parallel faces that we call the bases. And the other faces, we call those lateral faces. You can also name a prism by using the shape of those bases. So if I'm naming those parts, again, lateral faces are going to be the faces along the sides of your prism. The bases are going to be, again, parallel to each other and congruent, so meaning they're the same size and shape, and they should also never touch. So I have a triangle on the top, triangle on the bottom that's the same and doesn't touch. Same thing over here. If I have the two bases on the top and bottom, that would be, it looks like a pentagon on the top, pentagon on the bottom. They're congruent, they don't touch. Those are the bases. So lateral faces, again, are along the sides. Lateral edges are just the sides, I guess you could say the line segments that connect one base to another. So lateral edges, lateral faces, we have two bases. And again, we name it based on the base. So if I have pentagons as bases, that would be a pentagonal prism. And if I'm using triangles as bases, I would just call that a triangular prism. Altitude we can also refer to as the, in a prism, as the perpendicular segment that joins the planes of the two bases. The height of the prism is the length of the altitude. A prism can either be right or it can be oblique. So again, the actual segment we call the altitude, the length of that segment we call the height. So right prisms would be your examples on the left here. Again, the altitude is perpendicular from one base to another. In the second figure here, the height's actually going horizontally because my bases are on the left and the right. Those are, looks like trapezoids that are parallel and congruent. So I could have my height either going vertically or horizontally as long as I'm going from one base to another. So right prisms, I'm going directly using a lateral edge as an altitude. So right prism, lateral faces are rectangles and the lateral edge will be an altitude. In an oblique prism, on the right-hand side, some or all the lateral faces can be non-rectangular because if I'm going up the side of that figure, again, the height is still perpendicular from one base to another. Height would also be, in this case, perpendicular from one base to the other. But if my sides are not going up at that same right angle, that would be an oblique prism instead of a right prism. So for our problems, usually we're going to assume that all of our prisms are right prisms unless we have specific examples otherwise. So usually you're going to assume that case on the left. If I'm also trying to use that to find surface area, first we can talk about lateral area. Lateral area of a prism, the sum of the areas of the lateral faces. So remember, the lateral faces are all the surfaces on the sides of your figure. And if I find the areas of all those sides, that would be the lateral area. So if I'm looking for surface area, I'm taking the sum of the lateral area, and I'm also just adding in the top and the bottom, so I'm adding in the area of the two bases. So if I took my rectangular prism and unraveled it, we can imagine the surface area as being all of the lateral area, so the part that is contained by all of the sides, and also the top and the bottom are my two bases, so once I add in both of the bases, that would be the entire surface area. So with my lateral and surface area formulas, the lateral area of our right prism is going to be the product of the perimeter of the base and the height of the prism. So that would just be perimeter times height. And remember, perimeter in this case is not perimeter of an entire figure. It's not a perimeter of the entire prism. It's just the perimeter of the base itself. So P in that equation just stands for the perimeter of a base because both of those bases should have the same perimeter. So if I want to find surface area, I'm just going to take that lateral area and also just add in the two bases because again, we just take the sides for lateral area. If I want surface area, that's also just adding in two bases. So that capital B in the formula is the area of an entire base. So not just one measurement you're going to see in your figure, we should be able to calculate that as an area depending on what type of prism we have. So in our first example, if we're trying to find that surface area, again, that's going to be the lateral area plus both bases. So another way you can write that surface area formula, the way that we had originally was lateral area plus 2 times the base area. We could just include that lateral area formula, so I have that all at once. Perimeter times height is the lateral area, 2 times the base, that'll be added in to find all of the surfaces. So for the first part of that, I'm going to have to find a perimeter. So perimeter, if I'm looking at this triangular prism, should be the perimeter of one of those two triangles. And again, since they're congruent, I just have to find one, I don't have to find both. I can find the perimeter of this triangle since I know that one leg is 3, the other leg is 4, and if I also know it's a right triangle, I can use Pythagorean theorem to find the hypotenuse. So if I did 3 squared plus 4 squared equals c squared, that would tell me that c eventually is going to be 5. And you can also remember that from your Pythagorean triples. 3, 4, 5 is always a right triangle. So if I find the perimeter of that triangle as a base, 3 plus 4 plus 5, that should give us a perimeter of 12. For our height for our prism, our height is given to us, this 6 along the side. Again, as long as I'm going from one base to another and I'm going perpendicular, that would be a height. So 6 is my height. And for the base area, that capital B, again, for our bases, they're going to be using triangles. So we're going to use the triangle area formula. Triangle area is 1/2 base times height. And for our triangles, again, it doesn't really matter which one's base, which one's height. We're using a 3 and a 4. So if I use 1/2, 3 times 4, the area of one of those triangles should be 6. So putting that all into my surface area formula, again, I have perimeter times height. So that's 12 for a perimeter of one of those triangles, 6 for the height of the prism, and also 2 times the base area. So 2 times the base area of the triangles, which we found was 6. If I put all that together, I get 72 and 12, so that gives me 84 square centimeters for surface area. So if I try that again with a hexagon, we're going to see that it just takes a little bit more work to find the area of a hexagon compared to the area of a triangle. The other parts are pretty similar. For that surface area, again, we're going to start with a lateral area, perimeter times height, and then we're also going to add in the 2 bases. So for the perimeter of your base, again, your base in this case is a hexagon. I have a side length of 6, and I also have 6 congruent sides. So if I do 6 times 6, that gives me 36 for the perimeter of a base. If I'm looking for the height of that prism, again, height doesn't always have to go vertically. As long as I'm going from one base to another and I'm going perpendicular, from this front hexagon to the hexagon in the back, that would be a length of 12. So that would be my height. If I'm looking for the base area, this is where we have to go back to our last chapter and remember how to find the area of this hexagon. And going back through those steps, if I know that the side length is 6, I know that if I look at half of that side, that's how I'm going to form my triangle to determine what my apothem is. Remember, the formula for those regular polygons is 1/2 apothem times perimeter. So since we already have the perimeter, if I just want to find the apothem, remember we have to find our steps to take 360, divide it by however many sides we have. Since that gives us 60 degrees, we're going to cut that in half and find that in our right triangle, we have 30 degrees in the middle of our figure. And that'll always be consistent for a hexagon too. If I know that 30 degrees is in the middle of that right triangle, that means it's a 30, 60, 90, which means that for your apothem length, I take that short leg, which was given to us first as 3, and multiply that times rad 3. So our apothem ends up being 3 rad 3. So same steps from the last chapter. Those might be good to review with me if you're stuck on that, but we are using our same formula, 1/2 apothem times perimeter. And if I'm using that for the area of one of those bases, we should get 54 rad 3. We can leave that as a radical also for now. So now that I'm taking those parts from my formula, again, for surface area, I just need perimeter times height, so that's 36 times 12. And then for 2 times the base area, we have 2 times that base area we just found. So that's 54 rad 3 for one of those hexagons. Again, the 2 is just there to say that we have 2 bases. So if I add all that together, I have 432 plus 108 rad 3. Those are actually not like terms, so if I was leaving that in radical form, that would be my answer. Or if I do add those together on the calculator, that should come out to about 619.1 square meters. So again, finding a hexagon area is going to be part of finding that prism surface area, because we have to be able to find the 1/2 apothem times perimeter for the front and the back. So make sure that we could find those steps should be the same no matter what type of prism we're using. But we also have, besides prisms, talking about cylinders, which are pretty similar when we're finding surface area. First of all, though, a cylinder is a solid that uses 2 congruent parallel bases, this time that are circles. So they're still parallel and congruent. This time, instead of a prism using polygons as your bases, this time a cylinder is going to use a circle. So an altitude of a cylinder is a perpendicular segment that joins the planes of the bases, and the height of the cylinder is the length of that altitude. So pretty similar to our prisms. Again, the height will just go from one base to another. In this case, the bases are always circles, and the height could either go vertically or it could go horizontally. Just depends on where your bases are. So for our cylinder, we have bases on the top and on the bottom, and in this case, they'd be on the left and on the right. Those are your 2 bases still. And we also have, just like our last example, we have right cylinders and oblique cylinders. In a right cylinder, the segment that joins the centers of the two bases is an altitude. So if I go from one base to another, straight through the middle, that should be perpendicular if I have a right cylinder. If I have an oblique cylinder, if I go from center to center, that should not be perpendicular. But I should still have a height as long as I measure a segment that goes perpendicular from one base to another. I still have a height, it's just not going to be in the middle of that cylinder. So also with our last example, we're going to assume that any cylinder we're talking about is a right cylinder, unless you're drawn or given some specific example otherwise. So if we want to find the area of the curved surface of that cylinder, which would be in this case your lateral area, we can visualize unrolling that entire cylinder, and then the resulting rectangle is going to be that lateral area. So again, if I had a cylinder, but think about flattening those sides, if I took that and rolled it out, that would form a rectangle, and that rectangle itself is the lateral area. And just like with prisms for the surface area, we're going to start with that lateral area, but also just add on both bases. So the surface area is the sum of the lateral area and the two circular bases put together. So we should have lateral area as a rectangle and two circles to use as the bases. So for those formulas, we're going to be using those concepts. Lateral area of a right cylinder is going to be the circumference of the base and the height of the cylinder. So kind of like where we used perimeter last time, this time instead of perimeter, we're just using circumference. So circumference can either be 2 pi r, or it can be pi times diameter. But either way, I'm taking that circumference and multiplying times the height. So pi times diameter multiplied times height, or also 2 pi r multiplied by the height. So if I also want to find the entire surface area, that's taking the lateral area, but also remember we have to add in the two circles. So if I write that as lateral area plus 2 base areas, I can also find each part I need in that formula just by putting it in these terms. So this is the equation I usually use for the surface area of a cylinder. We're writing out the exact pieces we need for the lateral area, 2 pi rh. And also for those two circles, remember the area of a circle is pi r squared. So since that's two circles, that's 2 pi r squared. Remember also we see that capital B is going to still be the area of the base, which in the cylinder's case is going to be the area of that circle. I'm going to stop the video there so we can practice some of these together in class, but make sure we have all the notes up to here so far.